So, hello everybody. My name is Michael, and today we are going to talk a lot about OpenTelemetry and messaging system. Um, but this is a session that is specifically to OpenTelemetry and messaging system. It's not related to Aspecto, so you can feel free to ask any questions that you are interested in that topic, in that area. So let me get started. So our goal is really to see how OpenTelemetry can help you with messaging systems. We would see, in general, what is OpenTelemetry and how it works, why it's so important in messaging system. That would be probably the first portion of this session. And probably most of the session would be a live coding session where we start by implementing OpenTelemetry in a very simple way and start to work our way up in a more complex scenario and see what we can do with that. So um, when we are developers, we usually solve problems. So let's start by trying to understand what is the problem that we're going to solve today. So I'm going to show you kind of a diagram of kind of a system, a very simple distributed microservices system that doesn't have a messaging system yet in it. So we have service C, and service C is communicating with our database. And we also have service A. So you can see some browser is calling service A, calling to service C, calling to the database. And we also have service B. So the same browser communicates with two services in this scenario, both in which would end up in service C and we would write to the database. So this is, a very simple scenario of microservices distributed system. And that is all great, but the problem starts when we have issues. And let's say that we have some issues with service C. Maybe we have high latency. Maybe we have an increased amount of errors. So an important question would be, does the issue in service C happens all the time or specifically to, API calls from service A to service C or from service B to service C? So if I were to tell you that every API call from service A to C works, but with service from service B to service C doesn't work, that would be a very significant clue in order to resolve this issue, right? Because now I know where to look for the problem. Service A has nothing to do with this issue. It's probably service B. And this is something that in distributed application may be hard to understand. But when we start to introduce messaging systems, and by messaging system, I mean Kafka, SQS, RabbitMQ, Redis PubSub, all of those asynchronous communication, things started to get more complex when we implement in our system. So now I took the same architecture and I introduced some messaging system. Let's say Kafka, for example. So what happened in this scenario is that service A would write to Kafka and service B would write to Kafka. And let's assume for a second that service C consumed the messages both from service A, from service B under the same topic, under the same queue. In that scenario, when we ask the same question that we asked earlier, where is the problem? Does the problem originate between service A to C or B to C? Now that would be very hard to understand when talking about messaging system, because I really don't know when I'm getting a message, who I'm getting it from. And that's the whole concept, right? We want to have a distributed system. We want to have a system where we are not coupled between components. So we created messaging system exactly for that. So from architecture point of view, that's great. From operation, maintenance, incident response point of view, that is just making this story more complex. So what's the problem that we're trying to solve? We're trying to solve this complexity. We're trying to have a better architecture, but still be able to respond to incidents fast and accurate. So that's how I described the problem. And if we have a problem, of course, we will have a solution. And I would argue that the solution is distributed traces. And if you're not familiar with distributed traces, OpenTelemetry, we will start from the beginning of what it is and how it works and work our way up. So traces, let's see what a trace looks like. I'm going to show you a kind of a diagram, a visualization of a trace. I'll try to explain what we see there and kind of highlight the importance of what we have in a trace. And then we will go and understand how we got this trace, what we needed to do in order to have this trace. So let me introduce you to a trace. This is how a trace looks like. Well, at least in Jaeger, which is an open source tool that does a lot of things, but mainly it displays and visualizes traces. So let's try to understand what we see here. At the left side of the screen, you can see this tree view describing which operation we had within the trace. You can see here that we have three different services. We have the order service, the user service, and the stock service. So we have an application composed of three different services that communicate with one another. And we can see the relation between each event. So you can see that the order service got an API call to purchase order. Because of the API call to purchase order, the order service communicated with the user service. And the user service, in order to validate the user, probably needed to do something with, I don't know, this JSON. After that's done, the order service communicated with the stock service, which communicated with the database, and so on. So a trace, in a sense, is a tree view. It's a tree data structure, a parent-child data structure that is telling us who communicated with it. So if I were to look at logs, I would be able to see a specific log. I would be able to see a log saying, now I'm verifying user X. Okay, that's fine. But when talking about traces, I know that we try to verify that user, and I know why. I know that we wanted to verify the user because we needed to purchase an order. So that's the left side of the screen. That's understanding what happened and in what context. The right side of the screen is mostly performance oriented. So I can see that the overall request took about half a second, and the user service was very, very fast. And I can see that the user service has to finish before the stock service could have started. So we can see this kind of timeline to understand what happened when, what happened in sequence, what happened in parallel. So I said at the beginning, I refer to each row as an event. That would be wrong from OpenTelemetry terminology, because OpenTelemetry refers them to as spans and not events. The reason that they're called spans is because they span over time. They start a specific time and they have a duration. That's why we should call them spans and not events. So this is how a trace looks like, and I think that is a great thing that you want to have in your system, because it's really going to help you to debug your application. The next question would be okay, you solved it. I want spans, I want traces. What should I do? And the answer would be OpenTelemetry. So let's do a brief overview of what OpenTelemetry is. So OpenTelemetry, it's an open source project under the umbrella of the CNCF, the Cloud Native Compute Foundation, the same foundation that is responsible on Kubernetes. And it's actually, OpenTelemetry is actually the second most popular project in CNCF. So what this project does. So at the base of it, it's a specification, the same as you have, specification for HTTP 1 and HTTP 2. So this is at first specification that specify how you should collect traces, logs, and metrics. So OpenTelemetry is not only about traces, it's also about logs and metrics. It's definitely most known for traces, but it can also and should collect metrics and logs as well. So the reason it's first a specification, it's for a couple of reasons. So you need to be able to collect this data and ship it somewhere and ingest it and visualize it. And there is many vendors out there and many open source tools out there that are going to use it and are using it. So we first have this kind of specification. So everybody would use the same way to collect and the same way to send data. So the second thing would be we have a specification of the data that we want to collect. Now we need to actually collect this data. This would usually be done by an SDK, a package, a library that you import within your code, and you would have implementation in different languages. Most languages, and definitely the famous ones, do have already an implementation in this specific language. So you just need to take this SDK and then implement it in your service. Now, all of this data that we're going to collect, again, the traces, logs, and metrics, using this SDK needs to be sent somewhere and needs to be ingested. So we have some backend that can ingest it. So this backend will ingest all the data, do something with it, and then send it to a database, or send it to some vendor, to an open source, do a whole bunch of things with it. So I think an interesting question. So what's the difference in OpenTelemetry and frameworks like Elk and Splunk? So OpenTelemetry, it's just the collecting part. It's just the way that you are going to collect this data. It's not about how you're going to persist it or how you're going to visualize or which analytics you can run against it. It's just collecting and shipping it to the right destination. Different monitoring vendors add different kind of SDKs that you could implement, but this is the first time that we have a community-driven SDK data format that you can collect it. That means a lot of stuff that you can do with it and not be specific to one vendor. Okay, so why is OpenTelemetry getting so popular? I think because of four main reasons. The first one would be it's collecting metrics, logs, and traces together, but it's not only collecting them together, it's able to correlate between them. So trace can point to a log can point to a trace, metric could point to a trace, and this correlation makes it very, very easy. In different scenarios, you would start debugging an issue from a trace or from a log, so you can jump between them. The fact that you have one specification means a lot of things, but I think the most important one is that you're not locked to one vendor. I'm saying less vendor locked because you're never free from your vendor. It's not just easy to migrate from one vendor to another, but shipping the data from one to another, it's very, very simple. So the vendor lock that we have today won't exist. So OpenTelemetry is very, very powerful in that. And traces create a context between all of that, and it's not like a single event. Okay, so now that we kind of have an understanding of what OpenTelemetry is, and we know that we have an SDK, and we know that we have a backend, now we can try to understand how it really works. So I have here in front of you a very simple application. So we have service A communicating with service B. As you can see, I have implemented in both services OpenTelemetry. OTel stands for OpenTelemetry. So service A communicates with service B, and then we do some query against the database. And we have an OpenTelemetry collector. The OpenTelemetry collector, that's the backend that I was telling you earlier that can ingest the data and then ship it wherever we're going to define it to. So the first thing that is going to happen in this scenario is service A is going to send an API call to service B. Now, if you remember, earlier when I showed you a trace, I showed you this kind of a data structure of a tree view where we have a parent-child relation. So service A can report, hey, I sent an API call, and service B can report that I got an API call, but we want them to be correlated to one another. For that, we need to have some context. So what OpenTelemetry is doing when they're going to jump from service to service, they're going to inject an OpenTelemetry context from service A to service B. That means that when service B is getting the request, he knows exactly from who he got it. And the way that it works is like that. So service A will report, hey, I'm sending an API call to service B. Each trace in the system has its own unique ID, so trace ID number 1. And we have a span ID, which is also unique, and that's span ID 55. In this case, we have no parent because this is the root of the trace. That's the first event, that's the first span in this trace, so it has no parent. When service A is going to send an API call to service B, it's going to inject two important things in the context. The first one would be the trace ID, so we would all be under the same trace ID. And the second is the span ID. That means that when service B is going to report, hey, I got an API call from service A, it's going to look the same trace ID, so trace ID 1, a new span ID 66, but the parent would be 55. And this is the context that I was referring to. Now we understand not only what happened, we understand why it happened. Service B got an API call because service A sent it. And the same would go to the database call. Trace ID number 1, span ID 77, and the parent ID would be 66. So that's how OpenTelemetry works in general. And remember that in HTTP, we use the HTTP headers to propagate the context, the OpenTelemetry context, and we would see in different messaging systems, different implementation for that. So that's how the OpenTelemetry works. The overall stack that you probably gonna need is an OpenTelemetry SDK implementing all of your services, and this data could be shipped directly to a vendor or to OpenTelemetry collector that you're managing, and then you're probably going to have a database for that, and then you're going to have something to visualize that on top of it. For today's demo, I'm going to use a simpler version of the OpenTelemetry stack or deployment. So in this case, what we have a Jaeger all-in-one image that we will see in a second. Okay, I see that we have a couple of questions. Maybe I'll answer them just before we're going to jump to the live code. So what's the purpose? Oh, yeah, go ahead, Ron.
No, go ahead.
So what's the purpose of trace ID? Can we derive all information from span ID and parent ID? So the purpose of trace ID is kind of a root ID for all the different interactions. So you can search for specific span ID, and then if you want to find all the rest of the spans, you can start and look for different by looking at the parent ID, but the trace ID is kind of an aggregate ID for the entire transaction. And the second question was, most of popular monitoring services like Datadog also have context, right? I mean, in their SDK. Yes and no. So you are right that some of the monitoring services like Datadog would have some kind of context propagation. Usually it would be not as comprehensive as in OpenTelemetry. And also, I would say that because it's it's very specific to Datadog, only if you have Datadog all over your application, you will enjoy this context. If you have OpenTelemetry all over, and you can then send it to whoever you want. So you're kind of locked into their way of propagating the context. And if you want, for instance, to have more context, it's hard for you to do it because it's their SDK and not an open source one.
Yeah.
And yeah. Yeah, go ahead.
Maybe one last thing, Michael. Yeah, about the context propagation. So, is the trace ID changing at each hop, or is it something that is maintained across the system?
So um, every I'll make sure that I understand correctly. So service A and service B communicate tons of time between one another. Each communication would be different. Of course, that if service A calls service B and service B would call service C, yeah, that would also have the same trace ID. Trace ID represent the entire transaction.
Yeah, and it looks like it's an interesting topic. So, just to clarify, how do we determine when a trace started and when a trace ended? How do you know the root of the trace if you have so many transactions?
Yeah, so when OpenTelemetry in service A gets the API call, it starts. Let's say that it starts from an API call from the browser. So what OpenTelemetry would do, it would look at the HTTP header and it would ask, "Do I have OpenTelemetry context there?" If it has, that means that I am not the first one. If it doesn't have it, it would start a new context.
Got it.
Okay, so let's drive. Let's start to look at our code. So I'm going to show you an application um, that is fairly simple. We're going to start off with something simple, a Node.js application. So let's look at that. So I've chosen Node.js because this is my day-to-day programming language, but everything that I'm going to say applies to most programming languages. Um, so probably if you're using some other language, it's going to be the same. So I'm going to start very simple. As you can see here, I have some API call, an API call to /users. And when we are getting the request, if I got some query string telling me to fail, I'm going to log that I failed to fetch the users and then return 500. And if everything works, I'm going to make some external API to fetch some data from a mock service. So I'm going to fetch a list of users, and I'm just going to respond with that. So it's a very, very simple application. You can see here that I'm already running the application. And let me just show you that it actually works. Where is my postman? Here is my postman. So I'm going to call to /user. I'm calling /user, and I got here a bunch of users that I can see their data. Very simple, and we want for the basics of this talk to see that it works in terms of OpenTelemetry. So what I needed to do in order to get this data, I want to see a trace for this API call. So in order to see a trace for this API call, I have a tracer file which I invoked. And you can see here I have the tracer file. And let's review the setup process. So at first, I defined the name of the service. That's our user service. Then I started a node tracer provider. That's what is going to make our traces. I'm going to export this data to Jaeger. Let me make it a bit more readable. So I'm running Jaeger locally. I'll show you in a second where I'm running it. So I'm running it locally, and I'm exporting all the different spans that I'll create to Jaeger. And I have started here 3 different instrumentation: HTTP, Express, and Kafka. HTTP, of course, is the HTTP an instrumentation for the HTTP module. Express is a well-known REST framework in Node.js, and Kafka, well, that's the implementation for Kafka. So all I needed to do is these lines, and of course, to initialize it. And as you saw earlier, I sent a request right here, and I have Jaeger running locally. I'll choose the user service, I'll find the traces, and you can see that a few seconds ago, I got this trace. So this is the Jaeger UI again, and you can see that we got an API call to /users. And you can see here that we sent the API call to JSON placeholder, as we can see right here in the code. So this is all we needed to do in order to spin up Jaeger. All we needed to do is just have a Docker compose with Jaeger all in one, and you're good to go. If you remember in our code, I did a trick where if I'll add a query string for failed, that will be true, we would see something a bit different. So let's go right here and let's say fail equals 1. Now you can see that we got an internal error, and we would go back to our user service, fetch for the latest one, and you can see here that we got an API call, and the API call was errored because we returned 500 and we logged the console error. So this is a very, very simple initialization of OpenTelemetry. That's all you needed to do. And this is, of course, probably the most simple way that we can work with that would be an HTTP call. The reason that HTTP is so simple is for 3 main reasons. The first one, we're talking about one-to-one relation. I'm sending an API call to one service to another service. It's not going to be one-to-many. It's a synchronous call. That means that I know whether it's going to be successful or failed. So if I got status code 200, we're very, very happy with that. And we have a limited time to a transaction. Now we're going to make things a bit more complex. We're going to introduce messaging systems. With messaging system, we have 3 reasons that it's making that things started to get more complex. We have one-to-many relation. When I'm publishing a message, I don't know how many services are going to consume it, or maybe nobody is going to consume it. That's also an option. It's an async messaging. I don't have a result. I don't know the status code. Don't know when somebody consumed it, whether it was successful or not. And I don't know when it will be consumed. So you may have something that is writing to a queue, but only once a day you spin up a service that is going to consume this queue and actually drain it and process these messages. So this time transaction makes things a bit more complex. And now we're going to see 2 different ways that we're going to cope with messaging systems. The first one would be an automated way, and the second one is going to be a manual way. The reason that we have manual and automated is for one reason. So the question would be, in HTTP, we have a dedicated place to inject our OpenTelemetry context. So we would have a place that we are supposed to write metadata. We would write in the headers the OpenTelemetry context. So Kafka, SQS, RabbitMQ all have a specific place to write metadata. So we kind of are going to expect that it's going to work like HTTP. We see that it's sometimes getting a bit more complicated, but that's the general idea. We can automate it. In solutions where you don't have a place to the metadata, that means that you need to inject the context into the actual data. And this is something that won't happen automatically. This is something that you have to do manually because it changes the behavior of your application. For example, Redis PubSub doesn't have this place, and this is why we need to do it manually. So let's jump back to our code and see what I mean by having something that is automated versus manual. So I'm still looking at the user service. So the user service, it's going to fetch again all the users. It's going to create a producer, and we are going to send the data of the users of a specific user because we're using an ID here. So we are going to send it over the topic that we called send email, and we're going to say that this is 200 because it was successful. If something would go wrong, we'll have 500. So what this function is doing, we are getting the API call, fetching the data from external data source, and then publishing it to Kafka. Notice that we don't have any OpenTelemetry related code here. Now I'm going to show you the consumer of this service. So we have our email service, and the email service has a Kafka consumer. And you can see here that we are creating a consumer and we are subscribing to the send email topic. That's the same topic that we used in the user service. And we're saying to the consumer that he should run on each message, this is going to be invoked. The same applies as the previous service. We have the tracer file and we have the same tracer file in both services. So nothing too fancy here. And again, as you can see here, nothing special and nothing specific to OpenTelemetry. I do want to point out that the tracer has instrumentation for Kafka.js. So let me spin up the email service and I'll run it in a single mode that you will see later in this talk why I have single and multiple mode. So now if I'll invoke an API call to user, specific ID, email, auto, for auto instrumentation, we should be able to see the API call go through Kafka. So let's go here and you can see that I'm using the auto endpoint. Clicking that, we got an OK, everybody is happy. Let's go back to Jaeger and refresh our traces. And now you can see a trace. This is an HTTP post as expected. And you can see here that we have two services. We have the user service and the email service. So we got the API call. We made the external API call. We sent an email. This is our Kafka span. You can see here that it's Kafka. We have the topic, and we have the fact that it is a topic, and we have the receiving end of it. So we receive the message and we process it, and now everything that we would do under the email service would also be reported here. And this is, I would say, amazing, right? Because we do have Kafka, and Kafka is instrumented only by adding, a simple line of code right here, which is probably going to be a lot of work if you need to do it manually. Now, as I said that earlier, we are going to see two types. We have the automated option, and unfortunately, we also have the manual option. The manual option is doing the same. Again, getting an API call to /manual, communicate with the external API. I have some commented code here, but we are doing Redis publish to send email. And in our email service, we also consuming Redis messages, and we are subscribing to send email. And once we get the the message, we would write it. So far, we have nothing to do with with OpenTelemetry. Everything that relates to OpenTelemetry is commented out. Now let's see how it would look in case we are calling /manual. So I'm sending an API call to /manual and jumping back to Jaeger to see how this trace looks like. And you can see here that we don't have the email service. It's disconnected. We just have the two calls, the express call, the incoming call, and the outgoing call. And this is, of course, because we can't inject the context automatically. We don't have a place for that. Let me try and see if I can show you in the Kafka. So when looking at Kafka and you're sending a message, I think it's going to work. I'm not sure. You see that I have headers. That's what allows us to do it manually. Looking at the publish, so in publish, you don't have that. You just have the topic or the channel, and the actual data that you're going to send. That means that I need to alter the data and not the metadata. So here is a bit of a code that I written in advance. So let's review this code. So what I'm doing here is I'm going to API. The API, it's the OpenTelemetry API. So I have access to the OpenTelemetry API, and I'm going to ask to create a new span that is called publish. And I'm going to write some data. I'm going to write the user that I got. And I'm going to create it under the active context. So it would know where to put it in the tree of the different spans. And I'm going to inject the context into the payload. So I'm sending the payload over Redis PubSub. So I'm going to publish it. And within the data that I am publishing, I'm going to add the current context, then do the Redis publish and close this span. I know I haven't made a change in the other side, but let's see what happens if I call this API right now. So when I'm calling this API, let's see how it would look right now. So previously we had 3 spans, currently we have 4 spans. And you can see that we have a span for publish a message, and you can see here that it's Redis and everything looks fine. Now, if we want to be in the position where we have them both connected, we need not only to inject the context, but also to extract the context. So let's go to our email service, and we are in the consume Redis on a new message. And now let's review this code. So the first thing that I'm doing here is I'm taking the message that we got, I'm parsing it to an object, and then I'm going to extract from the payload the context, and again, create a span with the right context and then close it. That would create this communication between both ends. Let's see if everything works as expected. So I'll send an API call, go back to Jaeger, and we do have the user service with the email service connected to one another all together.
Michael, small question that, to be honest, I'm not sure I fully understand. I think it relates specifically to Java, but can we add the context in a form of aspect? For example, in Spring, you can use AOP to intersect and add details for context or parse context.
I think I don't know well enough Java and aspects to answer the question. I'll have to look it up. Okay, so what we saw here so far is we saw those 2 ends. We saw the way to things that are working automatically, and we're very happy with that. And the way that we need to work hard and to add specific code for OpenTelemetry for the context to actually work. So now I want to make things a bit more complex, because when you do a demo, everything is so simple, but in life things started to be a bit more complex. So when you're working with a messaging system, you're probably going to talk about batches. You want to have multiple batches when you're consuming messages. So different traces are going to be sent to Kafka. In this particular example, it's Kafka, but it of course applies to different services as well. So service A, service B, service C, all of them are sending messages to Kafka. And when another service is going to consume this message, it's actually going to consume a lot of traces into a single trace. So let me show you something interesting. In this example, where I'm going back to the Kafka example, so I'm going to send a bunch of messages to the auto. So the auto, again, is going to produce a message to Kafka. Looking at the consumer, I only showed you this portion of the code, which is consuming message by message. That means that this function is going to be invoked in a message by message manner. However, if you probably want to be a bit more performant, you're going to work in batch. That means that in a single action, I'm going to consume multiple messages. In other words, multiple traces into a single trace. So till now, we saw kind of a one-to-one relation, right? Because I have one producer, one consumer, and it all being the same trace. What will happen if I'll send multiple messages to Kafka and then consume it? So I have here a mode called multi. Multi would do exactly that. So before I'm going to spin this one up, I'm going to Postman, again to Auto, and I'm going to click it, let's say 3 times. 1, 2, 3. So those messages were sent, and now we are going to consume those messages. And this may take a few seconds because Kafka will work in batches. Okay, that was pretty fast. And you see, I spun up the service and I got all of them together. So try to think what we are going to expect from the user service. So the user service, we send 3 API calls, that's in 3 different traces. Will they have a Kafka relation or not? That's an interesting question. So clicking refresh, we can see that we have 3 new traces. Each trace is sending a message to Kafka, but the message is not consumed. We don't see the consume part. If I'll go to the email service, I'll see a trace where we are actually processing those 3 messages. So what happened here? As I showed here, we had trace 1, 2, 3, containing only the user service. And here I have one trace handling all those 3. So unfortunately, in Jaeger, you can't see the relation between different services. So you can't actually merge those 2 traces together, which is probably what you want to do from visualization and UI perspective. But from data perspective, what happens is you have 3 different traces and a new trace that is being created. And this is something that people usually don't expect automatically when they're starting to work with OpenTelemetry. They expect to see everything in a single trace. But when talking about messaging and batching in messaging, that's how it would look like. So just to make sure that you're ready. So that's what we just saw in our code. Just before we move on to the question section, would love to hear any question you guys might have. 2 things. We did an OpenTelemetry Bootcamp, again, free, vendor neutral. It's a 6 hours course split into 6 different episodes that we start from the very basic of OpenTelemetry to more advanced stuff and customizing it and managing it in production and sampling all of those things. So if you're interested, feel free to check it out. And after the question section, if you guys are interested, I'll show you our product Aspecto, which of course has a lot to do with OpenTelemetry. Would love to answer any questions that you might have.
Okay, looks like folks asked a lot of things during the conversation.
I have one question.
Oh, go ahead.
Hello. So I was going to ask, so we usually covered spans and traces, but I guess errors are also the part of the journey. And and during the dashboard, I also saw in your dashboard, I mean, in Jaeger, there were some errors actually in some of the traces. Like how they actually fit into the picture, like because errors are usually like instantaneous things, but also of course you can I guess connect them to a particular trace also at the same time. And what is the like how are you able to visualize it, for example, in Jaeger?
Yeah, so let me show you exactly that. So I did have a trace where we had some errors. Hopefully I'm able to find it. Yes. Okay. So what's happening here is actually we simply state that the specific span has an error in it. That's how we know how to to add this icon right here. And that's what telling us that it's not working properly. If you would want to record the actual exception, you could do it as well. So, if you would record the actual exception, just to show you that in my code, I didn't throw any exceptions. If I were to throw an exception, then you would actually be able to see when exactly the exception happened and the stack trace right here. So you can do that, and definitely always play a significant role in monitoring and correlating the thing.
Okay, thanks. One more small question. So is there a question about, I guess, both telemetry and Jaeger? Both of these things, are they supporting like connected errors? Like, because normally in Java, in Python, in all the other languages, in JavaScript also, an error might be happening due to another error. And usually the languages are supporting some sort of pointer to connect all these errors, like error.cows or error.from or something like that. So when you have a network error, let's say you have a root cause, maybe there's an null pointer exception somewhere during a network error, or maybe there's a syntax error. So when you report the error, is there a possibility for the user to see like all the actual errors, like not just one error maybe, but like a couple of errors at the same time?
Yeah. So there are two options that would be possible. The first one is that you just have different spans representing that error. So if you have an internal error in your database, that span would have the exception, the relevant exception, and then the HTTP layer would have the second one. That's option number one. The second option is that the exception that was recorded would have both or the chain. It kind of boils down to the way that the instrumentation was implemented. So I guess it would be different in different languages and different implementations of instrumentations.
Thank you.
Okay. Any other questions or?
Yeah, I think we can move to a quick demo that will include asynchronous communication as well. And if you still have questions, feel free to keep on sending them.
Okay, cool. So let me quickly open our playground. And so this is our system. This is Aspecto. And what you can see here is we took the main problem of Jaeger and we tried to make it a bit better. And the first thing that we noticed that people are having with Jaeger is the ability to search. If you go to Jaeger, the search is very, very complex. You either search by a specific service, and then you get a bunch of traces, or you need to have this tag mechanism where you can start a search for things, which is very complex. So we wanted to make it a bit easier. We do have a free text search here. So if you have a user ID that you reported, you can just search for that. Or maybe you don't know the user ID, you can just search for a free text search, and it will just go over all the different data that you collected and search for that. And also, you may want to look for a specific time. And you can see here that we can count and the amount of events that you got and have different breakdowns over the last 5 hours. And maybe you just know that purchase order post is doing a lot of problems and you just want to filter directly to that. So now that we find the trace that we're looking for and we click a trace, we are trying to make things a bit more visual. reading a timeline is great for performance, but it's hard when you have very big traces. It's hard to understand who's communicating with who, and having a visualization of that is a bit more friendly. So you can see here the order service communicating with the user service that communicated with Auth0. And if you click on a specific transaction, you can see all the relevant request data, response data. So you will have all the different data that you're looking for. And here you can see Kafka, as we mentioned earlier. And as you remember, this is the end of the trace, right? This is how OpenTelemetry works. So this is the trace ID, and this is where it ends. But unlike Jaeger, here I can see that my message was consumed only once. So if it wasn't consumed, it would be 0. If it was consumed 10 times, it would be 10. So I know how much time it was consumed, and I can see by which trace it was consumed. And I can actually merge those two traces together. So right here, I can see that my message was consumed, and I can see the message itself, and I can see how it was handled. And this making it that it's very, very easy to track and understand how messages are propagated throughout your system. So this is looking at Aspecto in a very short and oriented to the thing that I guess interests you the most, messaging systems. So I hope you learned something new today. And thank you very much for your time.